Hi folks, I'm Ferris Equus, and I'm a West Coast train nerd. You may recognize me from a few of Hyce's videos, although probably not in the way that you're thinking of. Here, let's take a look. This is a video that Hyce released 2 weeks ago, a Railroads Online video where he and kAN go around and do silly things with trains. And while they do it, kAN, who doesn't exactly know very much about railroading, he knows some things. And Hyce is definitely much more knowledgeable, seeing as he works for the Colorado Railroad Museum. And so oftentimes they talk a lot about railroad concepts. Seeing as I'm a West Coast railroader, I have a little bit different perspective than either of them, so I decided to leave a little bit more context in the comments. In fact, here's my comment right here. And I wrote a little bit. Actually, I wrote a lot of bit. Like, a lot of bit. This one comment actually is more than 1,200 words. And, that's not exactly sustainable. So instead of writing 1,200 words underneath every one of Hyce's videos to explain a little bit more, I decided I would make a video. So welcome to the inaugural episode of Context and Comments, the video, or West Coast Train Nerd Reacts, whatever this ends up being called. You'll find out when I do, when it's released. But I thought I would start making videos on all the new episodes of Railroads Online, starting with this one. So we tried running a train with no locomotive, which is already an interesting concept. So let's get started.
I'm gonna do an intro real quick for Mickey to edit in because he's been doing my edits lately.
Okay.
What's up, guys? This is Hyce. Today we're playing Railroads Online with my buddy kAN, and kAN had a really silly idea to run some cordwood. So let's see how it goes, shall we?
Hyce, it's that wonderful time of year. The sun is out, the birds are chirping, and cordwood needs to be loaded.
Unless, of course, you're on the West Coast, in which case it's sort of wet and miserable right now. But I'm sure we'll get over it pretty soon.
Yep. What else is new? It's another day. It's another. We need cordwood.
Yeah.
And we need more money because we're still broke, and we still.
I still wish you could convert the smelt.
What was that? I saw something. Something right there in the corner.
I still wish you could convert the smelter.
It's right there.
Another. We need cordwood.
Yeah.
And we need more money because we're still broke, and we still.
Aha! Right here. I see you, Mickey. Mickey, for those of you who don't know, is the editor of Hyce's videos currently, at least the Railroads Online ones, along with a few of the other ones. And I see you, and I think you're doing a pretty good job. So thanks to you and Hyce to come into some sort of agreement, because adding some of this fun stuff over the top, including putting yourself in the videos, is actually pretty funny. So keep up the good work.
I wish you could convert the smelter to burn coal instead of cordwood. And
that would be so much nicer.
Like, if you could swap it to be like, all right, swap fuel from cordwood to coal, and now you can actually supply it with coal, and it's a much better rate, because this cordwood loading business, like, every time we go past the smelter, it's empty on cordwood.
Yeah. I mean, I get why the ratio got set like it is, because they're trying to simulate truly how much cordwood a smelter would need to burn with a blast furnace to actually smelt stuff. But then they put the station for the cordwood in the worst spot. Like, it consumes a bajillion cordwood, but then there's no way to get a track in there unless you do what we did or build some ridiculous bridge structure over. You know what I mean? It could have been moved out. Yeah.
It would have been great.
Yeah, it's not ideal, and remember, like, the smelter got set up the way it was, and then the industries got changed, the ratios got changed, the economy got rebalanced later. But yeah, being able to change it over to coal, which has a lot more BTUs than wood, I mean, that would. Okay,
I said the keyword, which is BTU. BTU, for those of you that don't know, is British thermal units. It's something that engineers came up with a very long time ago, and it's one of those remnants of the, funny things that Americans take from other countries. It continues to be a national standard in some places, so it's sort of strange. But I did look up some data for this to give you guys some context of, why switching from wood to coal is so important. And actually, to illustrate this a little bit more, sorry, no actual illustrations. This is actually more of a story. The Southern Pacific, the famous oil route where, every locomotive on the Southern Pacific ran oil. It actually started with the Southern Pacific burning coal instead. Well, backing up a little bit more, the Central Pacific and all early locomotives were all wood burning, at least for the most part, because wood was plentiful, it was easy to get a hold of, and it was cheap. And cheap and easy to get a hold of are pretty good things when it comes to, running lots of locomotives all the time. To put it in perspective, the Southern Pacific had to get their coal from Wyoming, which is nowhere near California, where the Southern Pacific was based. And this was roughly between like the 1870s and the early 1900s. In the 1900s, of course, they switched over to oil because it was a lot easier to get a hold of on the West Coast. But for a good amount of time, they actually had to import coal all the way across the United States to do so. And the reason for that is for 1 pound of wood, and this is very abstract, nobody burns 1 pound of wood at a time, but for 1 pound of wood, you get about 6,000 BTU. And let's not worry about what a BTU actually is. That's something you can look up and investigate. But the context here is coal gives you 12,000 BTU per pound. So it's twice as efficient as as wood is. And that's, when you're twice as good at something, it's pretty obvious that you're going to win. And of course, you don't want to keep throwing wood into a firebox. It takes a lot of time, especially considering how much coal you have to shovel into a regular firebox. So imagine whatever coal you throw into a firebox and, doubling the amount that you need to throw in for a wood fire. It's just mind-boggling. And for those of you wondering about oil firing and why the Southern Pacific switched to it, bunker C fuel oil, which is like the dirtiest, junkiest stuff you can get. It's the stuff that's left at the very bottom of the distillation process. It's essentially waste oil, which is why the Southern Pacific used it, because it was cheaper than dirt. Almost literally cheaper than dirt. And that produces about 125,000 BTU per gallon. And of course, the conversions from gallons to pounds is not exactly the same. So there's a little bit of wiggle room in there. But, you go from wood to coal, you double the efficiency. You go from coal to oil, you boost it up a little bit more. It's readily apparent why railroads switched from one fuel source to another to try and, keep trains running for longer without as many fuel stops. And coal was plentiful. It's one of those East Coast things that you continue to pull out of the ground. So, it makes sense.
Would save a lot of struggle. That would be a really nice feature. So if you're out there, developers, please.
Well, the cordwood, after that though, there's nothing else cordwood would be used for then. If you convert it to
true.
coal.
I guess you would be done, because
you're literally your only purpose of cordwood is to make. We should honestly, what we should do. Okay, hear me out.
Actually, I believe that cordwood is still being used as the fuel source for your locomotives and railroads online. So when you put down a fuel depot with all the wood in it, you need to deliver cordwood to those in order to restock the wood. So I think that they're not quite correct on that one. You still need cordwood. It just doesn't go, they want it to not go to the smelter.
No, we build a line, right, that just goes up and up and up to the maximum steel bridge height from here, right? Okay. And then just goes over the smelter at that height, right?
Oh goodness.
And then you just like drop the cordwood off this steel bridge from 100 feet up,
I don't even know if that would work, but that would be hilarious.
It's a completely separate track from the original track, you know, so you could just have your cordwood trains just doing constant loops without any, you know, no effort at all. And
right, no interruption.
So what kAN is talking about sounds sort of like a tipple, which is a type of railroad infrastructure where it's typically for like coal or grain or you know, some other sort of loose media, not for logs, obviously, but loose media that you can carry around in a gondola or a dump car. And, you know, it's almost essentially that, where you would build a bridge, and then underneath that you would build hoppers where you could store stuff, and you would drive the cars out. You would dump your material into the hoppers below it, and then you could transfer that material onto boats or barges or, you know, other freight cars. So tipples are real things, and I don't think it's the same thing that kAN is talking about, because he's talking about like taking logs and dropping them off of like 140-foot bridges, and that's not something you want to do. That's just plain dangerous. Don't do that.
It's just, there you go, and then
this cordwood business is really, it's a fun business. Anyway, we're gonna do something fun today because we need to make cordwood exciting, because cordwood is just, it is not exciting.
Yeah, this is gonna be one that you don't try on your home railroad, folks. Don't try this at,
so it's all downhill. So we're just gonna
literally
give it
entirely downhill from here. Yes, just send it.
Yeah. It's got some flat sections, but that's fine. So we're just gonna kick it. We're gonna kick 9 cars, and then just ride them down the whole path.
see if we cannot pee in a cup on the way down. Which
yeah, I mean, it should be easy. We can actually leave the engine here. Like, we can leave Zuma here. We'll just teleport back later and come pick her up.
Okay, so what Hyce and kAN are talking about right now is called a gravity railroad, and the reason that it's called a the reason that there's actually a name for them is because they did exist. Gravity railroads were a thing, you know, for both freight and, very much surprisingly, passengers. They actually had passenger gravity railroads. Let me see if I have it. Aha. Okay, here's a book. This is called The Crookedest Railroad in the World. And it's about the Mount Tamalpais and Muir Woods Railroad out of Mill Valley, California. And basically, it was built as a entirely passenger tourist line, from the small town of Mill Valley, up the side of a mountain to Mount Tamalpais. And they actually thought it was a good idea to invest in gravity cars. And essentially what you would do is you would take these cars to the top of a hill, to the top of the mountain, and you would put an operator on it. Funnily enough, his title is Gravity Man. So a Gravity Man would get onto a car with a whole bunch of people, a lot of tourists, and then you would like free fall down the mountain. Of course, the Gravity Man is there to ensure that you don't like fall off the side of the rails or go too quickly. But they ran really successfully for a number of years at the turn of the century. So from about 1900 through the 1930s, I believe, they ran this route. Unfortunately, none of it exists anymore. They ripped everything up and it's been restored, and there's, you know, there are a few little bits and pieces. And to mention, the Mount Tamalpais and Muir Woods Railroad wasn't just a gravity line. They just happen to have a number of gravity cars on it with gravity men to take you down the mountain. But they actually ran a lot of geared engines, Shays and Heislers specifically. And it's just, you know, fascinating that they ran an entire tourist line with geared locomotives, you know, for the fun of it. And, you know, they were actually quite successful about it, too. The closest, you know, the Cass Scenic Railroad and the Roaring Camp Railroad come to mind, where they run geared locomotives for tourists. But back in the day, you know, you could you could have one wild ride down the mountain with a gravity man at the helm. It's just, you know, interesting to know that gravity railroads were real. And probably a lot a bit dangerous. So it'll be interesting to see how Hyce and kAN tackle this one, because it's probably going to be a wild ride.
Yeah.
And then I brought Betsy over to the smelter again, so Betsy can do the smelter stuff, and then I guess push the cars all the way back up the hill, and Zuma can come pick them up at the sawmill, and easy peasy lemon squeezy. We'll be
it is.
Good to go.
Living large. Yeah, it's gonna be nice.
Yeah.
But
Let's
dude,
just finish loading this nonsense.
Dude, Betsy was like the champion for the coal mine line. That was surprising. Doing the math, and it's like, wait a minute. How can Betsy outpull the Glenbrook? What?
Is it?
The answer is the Glenbrook has both pilot wheels and a tender, and I think Hyce talked about it in one of the earlier videos, but both of those subtract from your tractive effort, not add to them. And Betsy, with all 4 of her wheels being on the ground, really helps.
So I know, like, the gear trains have a better tractive effort just because they're so geared. You have a steam piston running a transmission that then gets geared down and blah blah blah. Did gear trains have multiple gears, or was it 1 gear ratio?
Some early ones did. Most were only 1 ratio set by the bevel gears on the trucks usually.
That was it. It was just like, this is what you get, and
this is what you get. But early climaxes, like we have in the game, an earlier version of the climax actually had 2 speeds, but you couldn't shift on the fly because it was not as simple as clutch and everything. Like,
okay.
You'd have to move levers, change gears out, and you had the low speed and high speed, but even high speed was not that speedy. So that'll.
Yes, high speed was not exactly a thing that geared locomotives did very well. We're talking the difference between 8 miles an hour and maybe 10 miles an hour at the max. And for the Class A climaxes that were so small, it's probably a lot less than that. Really, these things were meant to pull stuff. And for logging railroads, for industrial railroads, you needed to pull stuff. And you didn't particularly care how fast it did it. You just cared that you could pull it, because handling lots of product through little windy, mountain roads or industrial trackage or, light railway was what they were meant to do. Just because it was a lot cheaper to make it that way. So these, the climaxes with their 2 speeds, the Class A climaxes with their 2 speeds, is pretty interesting. And the Class A climax isn't the only geared locomotive that had more than 1 speed. I believe the enigmatic Baldwin geared locomotive. The Baldwin geared locomotive, for those of you who are unaware, is sort of a mythical beast, because there are pictures of it, and there are some sales pamphlets that Baldwin made to talk about it. But nobody really knows how it works. Basically, it was Baldwin's attempt to try and get into the industrial market, the same way that Shea and Heisler and Climax did. But as far as we know, they only produced 1 or 2 of them, and there are no pictures of them in service. There are no pictures of them, their gearing properties. We just sort of know that Baldwin tried, and then they disappeared off the face of the earth. So, Class A climaxes aren't the only ones, I think. The Baldwins also touted that they could too. But again, we don't really know, because I don't think there's any documentation that proves one way or the other what the Baldwin geared locomotives did.
Right
there.
I forgot that.
Cordwood heavy. Zuma no air brake.
Zuma don't stop.
Bring him back a half.
Yeah, Zuma don't stop very much.
Okay, now that'll probably be fine.
Yeah. I'm full brake, bro. I'm just there. We go.
We'll stop eventually. It's fine.
All right.
Yeah, the
gear trains had like multi-speed, but it would be like a low and a high, and then you'd have to set it, and then
you'd have to be stopped, take it apart, get the gear ratio set, and then continue. So if you were gonna run the climax up a hill, okay, well, we'll stop at the bottom of the hill, change the gear ratio, go up.
Right.
Or if you're out, you finish and you get to the flat section, okay, well, now we can change it out, put it in the high range. So there's actually surprisingly one of those.
I don't actually think that you physically had to swap out the gears. I think that the Class A Climax had something more akin to a steam automobile transmission. Obviously, there's no synchro mesh. This is back in the 1880s, but you could take one set of mesh gears and then pull a lever, and then they would swap over to another set of gears that you had to mesh. Just a note there.
This locomotive still survives for the Wild Goose Railroad, I believe is the name of it. Up in
is that a Canadian railroad? That sounds like a Canadian.
I think it's in Alaska, actually. But
okay,
it's
yeah, that would be.
Okay, I actually read an article about this recently. The locomotive that Hyce is referring to was in Nome, Alaska, and it's the only surviving Class A Climax. There are actually 2 Class A Climaxes out there, but one of them's a replica. It runs in Pennsylvania, I believe. But the Climax that Hyce is talking about was in Nome, Alaska, I think up until 2020. And then a group in Corey, Pennsylvania, which is the home of the Climax locomotive, and the Climax locomotive works, went out and got this locomotive. And I believe they're restoring it into some condition. I don't actually know if that's a operational condition or a cosmetic condition, but it's pretty great that they actually went to the effort to go and get this Class A Climax, because it is very much one of a kind. And it'll be interesting to see what they do with it. So the locomotive Hyce is talking about is still out there.
That would be the second guess. Is it's either Canada or Alaska?
Right. The Wild Goose Railroad. Yeah. So
Yeah.
I think it's the 313 is the road number, but it's a little itty bitty Class A Climax, and I mean it looks like a shed on wheels that has an engine built on it somehow. But it's got 2 speeds, which is very strange.
Now, if you have a gear train, right, the cylinders are on the side, and they're usually aimed at like a V towards a center crankshaft.
Only the Heislers have a V design. The cylinders are offset 90 degrees, and they have a central drive shaft. It's one of the geared locomotives.
Well, that's what a Heisler does, yes, but the other gear trains are. I mean, each one's designed. They're all kind of designed stupidly, if you ask me. But yeah, the Heisler is like a V-twin, so it looks like a V engine, like a gas engine, but they're steam engines instead.
Right.
Then the Shay, which is probably the most common of the geared engines, has the boiler.
The Shay engine is, in fact, the most common of the geared engines. I don't know if we have exact details on the number of locomotives that were built by any one manufacturer. I know for certain that the Shay locomotives didn't actually have, they don't have an exact count of how many there are, because they sort of fudged the numbers when it came to builder numbers on the Shay locomotives. But I think it's something along the lines of Climax produced, several hundred, and Heisler produced several hundred, and then Shay built several, many thousand. And I think the ratio is basically 2 to 1. So for every Climax that they produced 2 Shays. And for every Heisler that they produced 2 Shays. So Shay was very much more prevalent. And, there are a number of reasons for that. They were a little bit cheaper. I know that Lima definitely pushed the Shay a lot. They had great sales literature. And there are a lot of interesting things about what what the Lima works did to get Shays built. So it's no surprise that they're the most common.
Offset off to the left, and then it's got 2 or 3 vertical pistons off on the right, and the drive shaft to the right of the tracks.
Oh my god, I never realized the boiler was offset. This thing is so gross.
Yeah, that you start looking at Shays and you're like, wait, so you put all the weight on one side and you put all the kinematics on the other side?
This is like NASCAR. It turns better to the left than the right.
Yeah, actually, they actually had problems on certain railroads that were designed really, really with crazy curves that they could only have the shays face one way because the U-joints would lock up if they went the other way around the curve.
Actually, oh my god, yeah, and all the cranks are on the one side. That's okay. So I built an engine like this in Scrap Mechanic once with the piston engine on the side. So I built a shay. Good to know I built like the most terrible
Yeah,
one ever.
they're really not ideal.
Okay. They're I think as any of the viewers of Hyce's channel may know, he's not exactly the greatest fan of geared locomotives. But I think they're ragging on them a little bit hard in this case. The geared locomotives really they really played their part. And to speak specifically about them turning better in one way versus the other, the only known example that I can think of is the Uinta Railroad, where they had curves so sharp that they actually did gum up the works on a shay locomotive, where they would try to turn too hard and the trucks just ran into the drive shaft on the main cylinder casting. So this is it's not exactly that bad. Actually, I have some photos that I can show to give you a better idea, because the Class A, the small shay that they have in Railroads Online currently is actually the smallest type of shay, and it doesn't really give you the best idea of how offset the boiler is on actual shay locomotives. So I've actually prepared some photos. This is Shay Dixiana. She's the #1 at the Roaring Camp and Big Trees Railroad. Here's a side profile. You can see that she has 3 cylinders over here on the right side, and that's connected to a drive shaft that runs down the right-hand side of the locomotive, and it powers these 2 trucks with, pinion gears. But I have a picture of the front view, and you can see that her boiler is not just a little bit off. It's like a lot off to the side. And that's because you needed to put, if we go back a sec, you needed to put these pistons on the side of the locomotive to run the drive shaft. And so you needed to move the boiler over in order to fit the pistons there. There's debate as to how much this affects the center of gravity. Whether or not it made the locomotive more prone to tipping in one direction or the other. From what I've seen and the calculations that are out there, it's not great because the cylinders weigh so much. On a normal locomotive where their cylinders are down here or off on one side and the other, it sort of balances things out. But the cylinders actually weigh quite a bit. So having them offset didn't affect it as much as you might think. But it did affect it. And it does make shay locomotives a little bit weird in the locomotive world because they were never symmetrical. Actually, there are a few examples of people forcing shays to be normal. The great example is the River Rouge plant of the Ford Motor Company, and I'm sorry if I'm butchering the name of it because I'm not an East Coaster and I don't exactly know how to pronounce things, but famously, the Ford plant had a shay locomotive, and it was built like all the other shays were, with exposed gearing and an offset boiler. And somebody very high up at the company came by and went, "Oh, I don't like that. I want the boiler to be in the middle like regular locomotives." And so they actually modified this locomotive so that the boiler would sit in the middle of the frame. And you can look it up. There are some pictures of it. It's a rather strange looking locomotive. To give you a little context on this, here's another geared locomotive. This is a Heisler locomotive. This one actually predates the Heisler Locomotive Works. This is a Stearns Manufacturing 1899 patent Heisler. And if we look at the front of this locomotive, you can see that its boiler is basically straight down the center. So it looks a lot more normal. And the Climax too. Unfortunately, the Climax that's at Roaring Camp and Big Trees is currently being restored, and so it's in pieces. So I can't exactly take pictures of it that would make any sense. But I have a CAD model of one. So here's the side profile of the Climax, and you can see that it has the cylinders up at an angle. It's about 15 degrees. And that drives gears down here, and it drives gears in the trucks. And its boiler, too, is about centered, which, of course, makes makes it look a lot more like a locomotive. So I don't see why Hyce and kAN are giving the geared locomotives so much hate, but it is it is what it is. So let's get back and see what they're doing next.
But
yeah,
they
well,
they get a lot of torque and they do that, and then the Climax has cylinders that are usually canted upwards that then run a shaft that then goes to an internal or centered drive shaft underneath the engine. So a worse way of doing what the Heisler does, basically. And so they're all kind of whack.
The pistons on all these are all way smaller than the pistons on a traditional steam loco.
Typically, yes, because
they just get the ratio back with the actual...
Yes. This is also a thing that I can comment on. The cylinders on geared locomotives are, in fact, smaller. The Shay that I showed you earlier, Dixiana, I believe has 12 by 12 cylinders, so they're 12-inch diameter with a 12-inch stroke. And granted, it has 3 of them. It has more cylinders than a normal side rod locomotive would, which only has 2. But to give you some context, a regular mainline steam locomotive of a similar vintage had 25 by 30, which is 25 inches diameter by 30 inches stroke. And so, they were massive cylinders that were meant to move, the entire weight of a very long train. And geared locomotives just didn't need it because they made up for a lot of that lost tractive effort with gearing, because you can just multiply it, and it's pretty great.
Yeah. So the gear ratio usually somewhere on the order of like 2.5 or 3 to 1. You basically just get that as a multiplier on your tractive effort,
right.
And those numbers there are actually pretty close to reality. The Climax locomotive that I showed you actually has 2 sets of gears. There's a set of gears right off of the main piston rod drive shaft assembly, and there's another set of gearing when the drive shaft goes to the trucks. So its gear ratio is something like 2.25 to 1. Not exactly 2.5 to 1 or 3 to 1, as mentioned. The Heisler was geared about 3 to 1 in some cases, and the Shay locomotive was about 2. So yeah, but just about that. And of course, tractive effort.
You have wheel size multiplying against your tractive effort because it's reducing your leverage ratio at the wheel. Well, this is increasing your leverage ratio by having the gears. So it's just a straight multiplier with what the gear ratio is to get the tractive effort in the right place. How spotted is that?
I guess we should get out of the buy menu. That's good.
Cool.
At least the Climax and the Heisler, at least they used an internal drive shaft, though.
Centered drive shaft, yeah. They didn't have to have it off the side like the Shay. I mean,
yeah.
Those benefits of having it outside on the Shay is that it's easy to maintain and get to, because, I mean, all that stuff to oil, all of that stuff to take care of, and it vibrated apart more often than not. The Shay made it easier to deal with, so there was that bonus, which is why a lot of railroads bought them, because they were cheaper and easier to maintain when they knew that they were going to have to maintain.
Yeah, well, if I was buying...
So, that's that's somewhat true. Actually, if you look at the later geared engines, we're talking getting into the 1910s, 1920s, when they come up with superheating. The Climax locomotives were the first to switch over to piston valves and Walschaerts valve gear. So actually, all the stuff that you needed to maintain, all the valve gear equipment, which is what you need to maintain the most, is on the outside of the locomotive on the Climax, which probably makes that a bit more user friendly than the Shay was. The other thing to remember about Shays is that a few of the pistons actually face each other, because there are 3 of them. One of them naturally has to be in the middle, and that piston faces the side of another piston. And so in order to get to the valve gear and adjust your slide, you would need to do a few things in order to get it out, and that was a bit maintenance intensive. So more often than not, train crews just sort of left it alone, and if the timing fell out a little bit, they just sort of dealt with it because you have tons of power. You're in a Shay. So I think that out of the three of them, of course the Heisler has all the valve gear right in the middle, which is sort of hard to get to. And if you've seen Hyce's channel, you know that he has a video of one of the Heisler engines running. And, all that stuff being in the middle is sort of hard to maintain, so that one would probably be hard. But out of the three, I think the Climax might be the easiest to maintain.
Buying a locomotive built in some guy's garage would probably be pretty cheap. I mean,
you're not wrong.
The dude's literally sitting there like, all right, so I took some of those old steel milk jugs and I melted them down, and now we have a Shay. And it's like, bro, how did you do that?
Okay, this is a bit of an exaggeration. Even the geared locomotive assembly shops for their time were actually pretty state of the art. You have to remember that gearing is somewhat specialized in the 1880s when these locomotives were developed. So having geared locomotives means you actually have a pretty advanced shop. All the tools you need to make patterns, and the tooling to grind gears and that sort of stuff. These they were really advanced. I guess the out of all of them, the Lima plant was across the river from the main Lima building plant, so there are jokes to be made there. But the shops that built these geared locomotives were actually pretty advanced. As for building them in barns, that's very much like an early railroading thing. The Union Iron Works in San Francisco comes to mind, where it literally was just sort of some guy's garage, and they're like, yeah, we can make steam locomotives. And so it's not exactly as though people were just like, oh yeah, let's take stuff and throw it together and see what happens. The geared locomotive manufacturers are actually pretty advanced. Now, the people that use them, on the other hand, they were maintaining things in barns. You have a little insular railroad that's, like a logging operation or industrial thing, and you're quite literally in the middle of nowhere, so you have to do everything yourself. A number of geared locomotives ended up with, blacksmith parts, just because, that's what was available is blacksmith parts. And, not exactly built in garages, but the people who ran locomotives were maintaining them there.
Funny thing about Shays were that they were built by the Lima Corporation, and Lima was a locomotive builder back in the day. But they were built across the river from the true Lima plants. So Lima was well regarded and well renowned for making incredible superpower, very nice locomotives. They made some of the most modern.
You're talking traditional
steam engines, yeah, Berkshires and
big 280s or something.
284s, 484s. They built probably pretty much everything, but some of their super-powered big stuff is well regarded and well renowned as some of the nicest manufactured locomotives all time. So it's this is a really nice.
Of course, our favorite daylight locomotive, 4449, the last surviving GS4. Is a Lima product. So absolutely, Lima builds good stuff.
Nice manufacturer, but they had the stepchild, manufacturing plant across the river from where they made the big ones, and they made Shays over there.
It was so embarrassing for them, they had to put it across the river. That's basically.
Yeah, pretty much.
All right, so.
Actually, that's incorrect. It's important to remember that the Lima company, the Lima Machine Works, as it was known to begin with, was contracted to build Shays initially. We actually owe the existence to the Lima Locomotive Works to, Ephraim Shay deciding to build this hokey little locomotive, and soon enough it becomes a huge success. And I believe it's in the late 1890s or the early 1900s that they actually start building regular locomotives. And of course, they famously came up with the superpower concept, or developed a good amount of the superpower concept in the late 1920s, early 1920s, sorry. Where superheating and, large cylinders and feed water pumps and, all the things that make a modern locomotive modern, a modern steam locomotive modern, at least in the traditional sense. But no, I think it's somewhat incorrect to say that, that there was a stepchild plant where they stuffed the Shay because they didn't want to deal with it. No, that was the plant. The Shay plant started off as the only thing that the Lima Locomotive Works built, and then when they got into large locomotive, production runs, they actually built a second plant, and that's where the huge super-powered monsters start coming out, is because they needed something bigger to produce bigger locomotives, and the Shay was sort of put to the side. I also believe that there is a reorganization of the Shay plant to make it more streamlined, to expand out what was going on in the shop. But really, if you want more information, the place to look is... nope, not that one. This one. This huge volume, it's aptly named the Shay Locomotive, and it has absolutely everything that you would want to know about a Shay locomotive in here. It has reference data, it has the history of the company, it has the history of the locomotives, it has drawings, it has everything. It also costs a lot of money, which is why, this is definitely one for those of you that are hardcore geared locomotive buffs. But it's a wonderful volume, and they go through the history of the shops and how things progressed. So in this case, I think it's a little bit wrong to say that that there's this stepchild plant, and that's where they stuffed the Shays because they didn't want to deal with them. It's true that as the popularity of Shays declined, there wasn't much reason to reinvest in the shops a lot, because if it's not making you money, you wouldn't put much money into it either. So there are trade-offs there. But I think it's a mischaracterization on Hyce's part of what the Lima plant actually was.
Oh, there is a slight problem with using the Zuma for this. This is a slight, it has to be a slight, like this is the slightest hill, like it's like 0.5% or something, because
no,
it has to clear.
It's fine. Just said you can stop now. It's fine.
Oh, okay. Yeah, because it's like a 0.5% hill, because it's got to clear like a little crest going this way, so that's the only unfortunate part. But it's good. We can go back to kick this, and then we're just gonna
gravity will take over. Yeah, we'll be perfect. Yeah.
Once we get to that hill, gravity will just do the thing. I hope we just need to make sure we have enough momentum to go through the whole sawmill.
Yeah, and then, that's the biggest flat section.
Yeah, the sawmill all the way to the smelter valley, like at the top of the hill there, and then after that, once we're on the 2%, like we'll be set for life.
Yeah, that'll be nice and easy. That'll be more where the chance of P-cups happen, is down that way. Up this way with 0.5% grade and everything, it shouldn't be that bad. Knocks on wood, maybe.
All right, so geared engines in here, we have a limit. Obviously, we have a track limit of 10%.
Right.
At what point, first of all, if you make a cog railway, where you got like the gear teeth on the track, like the center gear teeth track, or I guess sometimes on the outside or whatever, was that something that you could just slap onto like a narrow gauge, or do they have their own gauge specifically for cog built engines? And then on top of that, at what point in time do they go, this is too steep without using a cog?
So in the States, it's really interesting that the history with using cog.
Briefly, before Hyce gets into an explanation about cog railroads, he actually probably knows a lot more than I do on cog railroads. Cog railroading isn't exactly a thing that we had out here on the West Coast, at least very much not prevalent on what I study. But to briefly touch on when you would switch from a regular type railroad to a cog type railroad, or let's say a cable railroad, about 10%. quite seriously, that's the limit you want to go with conventional railroad equipment. Anything past 10%, you start running into troubles with adhesion, with getting conventional locomotives to run properly. You have to remember that boilers aren't designed to go at all angles. They're meant to be about level or off a few degrees depending on what you're doing. Geared locomotives especially were built with more robust designs for boilers, because they knew that, you know, the people operating them weren't going to be using them on level ground. They were going to be going up hills. They were going to be hauling lots of freight. So there are different I'm going to go with different systems out there when it comes to railroad equipment for above 10%. And also your brakes. Think about the 1880s when you're using wood for brake beams. Is, you know, no matter how much you apply that handbrake, your equipment's going to start slipping at about 10%. So you can't really stop all that easily. And most logging railroads were resistant to adopting automatic air brakes. So for the most part, they didn't try to. And about 10% is where you would want to stop. And the reason I say 10% is because there actually is a railroad that runs at 10%. It's the Roaring Camp and Big Trees Railroad, where they run all those tourist line operations with geared locomotives. So you too can actually go ride a 10% line, because they have a switchback system, and when they built the switchback, they were sort of limited in where they could place it. So they basically ran it straight up the side of the mountain. And depending on your source, you can either believe it's between 9% and 10.5%. I generally tell people it's 10% because it's easier to understand that you go 10 feet up and 100 feet across to get the slope. So, yeah, 10% is where you want to draw the line. Of course, let's hear what Hyce has to say about cog railroads, because that's something that they had out there on the Pikes Peak.
Railways and rack railroads instead, they were usually just a dedicated, yes, this is all going to be a cog railroad, and that's that. Like, the whole railroad is that way.
And then you get a custom guy to build you a custom engine then? Like,
custom engines, everything set up like that. And like the cog engines we have at the museum, their wheels don't actually turn with the engine. The engine only powers the cog. So they have to run on a cog railroad. They can't run on any other railroad.
Right, the wheels are just there to support the weight.
Exactly. So, you know, we're a little different in the States versus some places in Europe or in Switzerland. They have really crazy looking steam engines that have dual adhesion and rack engines. So it's got one steam engine mounted on top of the other engine so that they can power the wheels, the rack, or both. And they look bizarre because it's got like 2 sets of valve gear, 2 sets of pistons and everything. And it's like, there's too many rods on this thing. What the heck?
That would be, you'd have to manage both throttles independently. Like, that would be such a pain in the butt.
Yeah, I don't honestly know how they operationally work. And there's still some that run. And I believe one of the viewers of my channel has commented that they're a fireman involved with one of those engines. So I'd love to
you're on the
chat him up a bit.
Right
I am,
now, right?
yes. I am on the leading cordwood car here.
Okay, yeah, no, I probably should save, but YOLO.
we are moving now, so it's fine.
So I guess I'll save anyway, just in case, because why not?
Yeah, it's fine.
Yeah, no, that's fine.
Yeah,
that'll be good.
It's
and
fine.
Then,
as if I've learned anything about running in railroads online, is you want to save just about as often as possible. It's like Skyrim. You don't exactly know what you're going to get into, but you know that something's going to happen that's going to put you on the ground.
I've got unpinned up here, so I'm going to basically turn off the reg here, turn on the brake, and then very quickly try and jump onto the cordwood.
Godspeed.
Which I can probably turn off the reg now.
We're scooting. We're doing a good 10, maybe 12.
Yeah, like, well, there's going to be a lot of momentum with these cars because the weight buildup.
They're heavy, yeah. So
the problem is just this corner. Yeah, no, they are definitely slowing down on these corners. Once we get to the main track, it'll be a little bit.
Got to get on that grade. We're gonna try and we got to really roll as far as we can down this hill without any brakes and see.
Yeah, we just gotta go no brake, I think, for the whole 1% and see what happens.
Yeah.
All right, I'm gonna literally just set the tender brake on this because then it'll eventually stop, and there we go.
All right, and you're on board. I'm on board. Now. Zuma's stopping and de-rendering because it's so far away from me.
Yeah, Zuma stopped. She's on the logging platform.
That's and now we ride downhill, and it's fine. Yeah, no,
there's no brakes tied on this, right? Like we're
yeah, not that I know of. I checked them all in the yard before we loaded up, so we
Why
should
does it
just
feel like we're slow?
It does feel like we're slow. This breaks off.
Okay.
Jumping over cordwood. We didn't realize
yeah, this was
that
the worst load to do this with.
Yeah, cordwood's challenging.
It feels like we are slowing down, but I wonder if that's literally just friction.
It might literally just be friction. I don't know. I'm gonna anytime that I jump off as a client, I start getting eaten by the cars if I try to get back on.
Don't worry about it. Just man that front brake, because that's gonna be the one that we're gonna use.
I'm gonna be the front brake boy. Yeah.
No, it's literally there's no brakes. I think this is pretty shallow because it just clears that peak. It's not really much of a grade yet.
Yeah, that's right. And then on this bridge, it starts to.
And then, there's a lot of corn here, so it's really shallow grade.
This is the slowest runaway train I've ever been a part of.
Dude, we'll be fine though.
It was 9 cars. I left
we're
it
not
at
gonna
0.
have enough speed. Like I'm worried we're gonna slow right down in the sawmill. You know?
Yeah, we might have to bring up the Zuma and give us another kick. Well, we'll see what happens. It's fine.
All right, so real life stuff. Longest gravity train that still exists or ever existed, or do they even run gravity trains, or are they just like, bro, you need an engine? Like, is it?
I don't honestly know. I know I've heard of some gravity runs before. I've heard of some runs where they'll use a loaded car on the way down with a rope attached to it that goes around a big pulley or probably a big steel cable or chain or something to pull the empty car up to the mine on the second track, so that they can use the weight of the loaded train car to just not need an engine. I've heard of things like that, but I don't know.
And then what? You flip the loaded car from the empty track over to you're basically like a chairlift.
Yeah, basically like a chairlift, but with train cars. Yeah. I've got no clue. I don't honestly know.
Work smarter, not harder. That's actually kind of smart.
It is. Yeah, and it would be neat. They've got a special name, and I'm sure someone in the comments will get it.
The name that Hyce is looking for is actually cableway. And there are actually quite a number of gravity-fed cableways. I think I saw a video recently here on YouTube where there's a gravity cableway in Great Britain that's been running for more than 150 years as they load either quarried stone or something like that on one side. And, there's a pulley at the top and a pulley at the bottom, just like a ski lift. And, gravity takes the heavy cars down and it brings back empty cars on the other side. And it's, pretty phenomenal. But the word he was looking for was cableway, because it runs on a cable. In terms of gravity railroads, I don't exactly know what the longest one is, but in terms of actual gravity lines, I believe the Muir Woods and Tamalpais Railroad, the Mount Tamalpais and Muir Woods Railroad, was about 4.5 miles of gravity line of purely dedicated, not dedicated gravity line, but the line that the gravity cars ran on was about 4.5 miles. And again, that's pretty insane. But if you happen to know of a longer gravity line, go ahead and leave a comment, because I'd be interested to know too.
They had a specific name for that sort of railway. To your question on cog railway stuff, most of the cog stuff is standard gauge still, actually. Although I think the Mount Washington cog, I want to say someone said that it's one of the 2 cog railroads that exists and operates in the States that I'm aware of. I think they're actually like 4 foot 8 inch. They just chopped off the little half, and they're like, yeah, no, it's fine.
Where were cog railways normally? Like, obviously in the mountains, but like for what purpose? To get up to like a mine or something? Or
I don't know of any that were set up for an actual mining operation or anything. The one that's near me, the Manitou and Pikes Peak Railway, was built in the 1890s as a tourist railroad. Literally as a, hey, take the train to the top of the mountain, because Pikes Peak is a 14,000
a whole ton of money
mountain.
But I guess it would have been a lot. You would have had to like walk up or something otherwise.
Yeah.
Yeah, it sounds a lot like the Mount Tamalpais and Muir Woods Railroad, where it's a tourist line. It was built as one, and its only job was to take people to the top of a mountain so that they could see stuff.
Yeah, you'd have to hike it or whatever. And now, I mean, they do like rally time trials and stuff up Pikes Peak in
Pikes
cars
Peak.
and stuff, the hill climb. But There's a
crazy.
railroad that goes up
If we're
it, too.
slowing down, dude, if we are slowing down like this, it's crazy to me because this is literally rolling friction slowing us down.
Yeah, well, I mean, plane bearings, they have a fair amount of friction to them, so. And
Like,
it is cold out. It's cold and snowing right now, which does affect the efficiency of a plane bearing. So you would notice that they would roll a lot easier in the summer than the winter. So I doubt that's coded in the game, but you
would lubricate all these bearings all the time. With,
oh
like,
god,
greases,
yeah.
right?
Every day you make up a train, your brakeman is going and checking all these cars because the hot box is a very bad day.
I cannot stress that enough. When I was in brakeman training, absolutely, your number one job. Okay, not your number one job. The number one job on any railroad for any railroadman is safety. But your job as a brakeman is to go and check all the journals, especially on heritage railroads, because you have these plain bearing type rolling stock, and you need to make sure that there's oil in your journal box, or your train doesn't roll properly. And I'll have to draw a diagram of this because it's actually quite interesting. But imagine that you have your axle, it spins, and there's a bearing that sits on top of it. It's about like this. The bearing is made out of brass or bronze, and the axle is made out of steel. And if you don't have any oil in there, typically there's a little thin film of oil that sits right here at the interface. And it means that they slide past each other pretty well, and it prolongs the life of your bearings, and it prolongs the life of the axle, and it does all these good things. But most importantly, it keeps the temperature down in the box. And if you run out of oil and the brass and the steel axle interact, it gets incredibly hot. I mean, like, set your car on fire hot. And in this olden days with, wood cars where you're hauling wood, your hot box could very quickly set the truck on fire, and then set your car on fire, and then set the load on fire, and then set the forest on fire. And of course, you're trying to sell what's in the forest, so it's probably not a good day that you've set everything on fire because of one hot box. So lubrication is key.
Yeah, you don't want to experience that. So,
all right.
Actually, there was something just recently that I just heard, and it's bugging me a little bit. Let's see.
And a whole ton of money to put. I guess it would have been a lot. You would have had to like walk up or something otherwise.
Yeah, you'd have to hike it or whatever. And now, I mean, they do like rally time trial. There's a railroad that goes up
if we're
it, too.
slowing down, dude, if we are slowing down like this, it's crazy to me because this is literally rolling friction slowing us down.
Yeah, well, I mean, plane bearings, they have a fair amount of friction to them, so. And it is cold out. It's cold and snowing right now, which does affect the efficiency of a plane bearing. So
It's this portion of it. I'm a mechanical engineer by trade, and so I actually know a bit about bearings and bearing interaction. And this confuses me a little bit because it's my understanding that plain journal bearings are actually pretty decent. I mean, okay, of course, starting plain journal bearings is something different, but once a plain journal bearing gets rolling, it's fine. Actually, I'm wondering if I can calculate this some way. This is going to be one of those incredibly long-winded tangents, and I don't actually know how long it's going to take. Let me see if I can find a book that'll give me a formula, and I'll be right back.
Soon after.
Okay, nope, not on that one. Let's see what's next. Let's try dynamics. Dynamics does that.
A few minutes later.
Okay, there was something useful in there, but not what I was looking for. Where else can I find this information? Maybe it's over there. bearings.
A little longer than a few minutes later.
Aha. Okay. I found the equations. Or at least I found the section that I'm looking for. So the Machinery's Handbook, which for those of you that don't know, Machinery's Handbook is probably, not to be sacrilegious, but this is like the Bible for mechanical engineers and for people that work in machine shops, because it has just about everything in it. And it turns out that it does have the equations for plain bearings and the friction loss associated with them when you have oil in them, which is incredibly useful. So I'm going to start looking into that and see if I can give you an answer really quickly on how much friction bearings would slow down your load.
Many minutes later.
I'm going to need a calculator. I'll be right back. Hello, TI-84.
A lot of boring math later.
Hi, folks. It's been a little minute because I've been trying to do, some equations I haven't seen before and math I haven't touched since college. And I've got like a few pages of calculations that I'm running through, and I don't actually have an answer yet. But I really want to know the answer to this. So I think I'm going to split this video into two parts. The first part, I'm going to end right here. But follow me in part 2, where I go over the results I find about friction bearings and how much, plain bearings, friction bearings. Technically they're called plain bearings. But I want to share with you the data so that we can, take some more context about what happens in part 2. So I'll see you in the next one. Bye.